Hello viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about solving Middle East's water crisis. And the primary reason for that is to stop water wars because that will have global consequences. So let's dive deep into it. Now, Middle East is one of those position that does have a lot of black gold but does not have normal water. So they were very water stressed from day one. Let that be very clear. It's not like they did something stupid and then they ran out of water. It's like they did not had enough water to begin with. So fundamentally, that was the problem. And again, it's not just like Iran. We're gonna focus on Iran today, but like similar-ish story on all of that. And all of them, ironically, you would think that they would be super precise with basically water, but no, basically either the places that have sorted it is like sorting it via brute force, basically just burning oil away, or other places are just like stuck. So fundamentally dumb management made it unsustainable. So they had a rough start and they made it worse, even though technically they could have made it exponentially better because they had all the resources for it. So that is bad. And let this very clear, this is not a like hee hee ha ha situation or like it's a minor inconvenience. No, it's a boom event, very close to an actual boom event. Sometimes Egypt is saying I'm gonna go boom boom with Sudan, and let's not even talk about Iran is like I'm gonna go boom this, I'm gonna boom that, beat Pakistan, beat Afghanistan, whatever have you. So things are serious, rather be very clear, and people are actually willingly ready to go full boom boom and actually poof each other off. So this is bad. And if we do not solve this, let's just say even war does not happen and like water crisis keeps getting worse, it will create a migration crisis for everyone. If that many people have to evacuate, yeah, it's not good for anyone. Even if your country directly does not get affected by it, it will be affected by it because of the indirect consequences of that much migration. So yeah, it is in everybody's best interest to make sure the people here can stay here. Again, not run out of water or things of that nature. That's a good start. So be it Iran, Egypt, or everyone in between, that's the whole point. Situation is bad. And current system that you will like, okay, if all of them have access to sea, why don't they just desalinate it? Well, here's the deal. If you are an oil nation, you do not want to burn your oil by yourself. You always want to sell it to others, not burn it yourself. Even Soviet Union knew this, because that's why you pay attention to Soviet Union railway and public transport. Why the heck their buses were electrified? In 70s, trolley buses. Why? Because they wanted to sell diesel, not use diesel. Why they were railway was so, even though it was going through such a remote area, sparse area, they worked so hard to have basically DC electrified railway up to 3000 or sometimes 4000 voltage, because they wanted to sell the minerals and resources, not consume them. So it's actually a very smart move. It gives you buffer room, it gives you immunity from market fluctuation, and makes your profit grows exponentially. So that's the whole point. Every nation here does not have the deep enough pocket of Saudi Arabia where they just can burn it. Other places like, dude, every liter we are burning here, we are losing our revenue. So it's not sustainable. That's why not every, even though most of them have enough oil reserves, they can't just like lol it. It burns public money. Even if you remove the part, like let's just say oil is not an issue, it's just that it burns public money. It's bonkersly energy hungry, so to say. So you have reverse osmosis, like what Israel is doing. The technology is bonkersly capital intensive, and it has brutal side effect from ecological point of view. The brine coming out of it is worse than multi-stage desalination. That's how bad it is. The concentrated energy content low, capital cost super high, and brine brutal. Multi-stage desalination, you can use it. Energy cost goes up bonkersly high, and brine is not as bad as reverse osmosis, but both of them will sanitize that area. Basically, if you have fishery, say bye-bye to fishery. So fundamentally, we have to solve this. And again, all of their lakes is just getting kaput, kaput, kaput. I've been saying for years, do not keep building dams. 1 or 2 dams away from equator could work. If you build dams this close to equator, like India, China, Iran, yeah, you're gonna bye-bye your rivers. And again, they did not even last it that long. I assume 30 years, no? Many of these are just kaput in 15 years ago. So we have, and again, this is a bridge. It was confusing to know, this is a bridge. This is a dried out river. I thought like, why it's a weird flyover? No, it's a bridge, ancient bridge. The river just disappeared. So situation is bad. So first tool that we have to deploy is PVT, aka photovoltaic thermal panels. What does that mean? That simply means you buy a normal solar panel, you put heat exchanger behind it, and you put insulation. So all the energy can be extracted in the fluid. Now, a lot of companies, a lot of European companies who are making this, mass producing this, I have no idea why the heck Indian industry has not looked into it yet, but This is something that we all have to do eventually, especially in India and China. If we do not, our solar farms will go kaput because the air temperature will be too high. Cell temperature would be exponentially higher, at least 30 degrees Celsius higher than that, meaning they will be cooked. So we have to basically have PVT rather than just PV panels. We have to have PVT panel. Technology is not that complex, mass producible, and people have already started doing it. Right now, if you have the money, you can just order it. So that is the good part. Now, what is the benefit of solar panel? Well, in this sort of scenario, when you have PVT, you will get panels that will last longer, meaning the degradation of your solar panel would be much slower, meaning this farm can produce the same amount of power 25 years down the line, simply because if you're cooling it. Another is it will give you more power also. So lifespan would be longer and the energy total generated would be huge. And when you're talking about something like gigawatt scale, it's significant. Let's just put it that way. It's significant difference. Now, how much cooling we have to do to get this all advantages? Well, cooling will depend on the ambient condition, meaning you will have a lot of sensors there, and that sensor will detect the dew point. Basically, at what point, if you keep cooling it down, water will start to condensate. You do not want water condensating because water will condensate, then it will evaporate away, then you will have salt left there. Not a good idea. So you will always be like, let's say a computer detects the, ambient humidity, you calibrate it, verify it, then it's like, okay, it's 25 degrees Celsius. You make sure you only come down to, let's say, 27 degrees Celsius, 2 degree, you do want some buffer. So you always have to be above dew point. So there should not be any sweating effect happening on the solar panels. You cool it. Now, what does solar panel give you for the water problem? Well, it gives you heat source. If you want to desalinate, you have to understand that even if you can boil water in almost 0 degrees Celsius, the phase change energy does not change. Like the amount of oomph it needs to go from liquid to gas is huge, like huge. You can depress the temperature required to make that jump, but you can't make the energy of the jump different, so to say. Basically, if you have like high pressure, you can make sure that it remains liquid up to 200 degrees Celsius. But when it will do phase change, it will take the same amount of energy. You can pull vacuum on it and it's like, okay, it boils away as quickly as, let's say, 15 degrees Celsius. You can do that. It will still take same amount of energy when it boils away. So basically, you can change the temperature, can't change the phase change energy equation. So you need bonkers amount of energy. Like we burn oil on this thing like there is no tomorrow. So we are talking about huge energy. So this panel will give you energy, and this is where it starts to shine. Solar panels are not that expensive. Even PVT panel with all the plumbings is only 2 to 3x the price. But here's the funny thing. From a solar panel's point of view, basically sun dumps almost kilowatt of energy in per meter square. 25% of it will be converted into electricity. Because these are cooled panel, you will get that number. And heat would be 60%. Now, it's like, why heat is only 60%? Most of the energy would be reflected, leak into the ambient, so you will not get 100% absorption, so to say. However, right now, things that are in market that you can just buy, pick up a phone and order, they give you 3:1 ratio, meaning if your plate capacity is 1 gigawatt hour electrical, you can easily, like easy, 3 gigawatt hour of thermal energy, meaning enough thermal energy to boil more than enough water for yourself. That's the critical part. You're getting electrical energy and you're getting thermal energy. And thermal energy is what we need. Electrical is just a byproduct. And heck, 50% of it you will sell back. So fundamentally. And why do we need to cool panels? Look into every solar panel. They will have something like this. Whatever manufacturer, whatever brand, they will always give you this basically temperature dependent output. And I have no idea what India is smoking. Our ISI, basically our international standards body, they rate the panels for 25 degrees Celsius. India is hot. 25 degrees Celsius is like a winter for us. Our summer temperature is 50 to 55 degrees Celsius. Cell temperature can easily be 70 degrees Celsius. So we need this graph, not like working 25 degrees Celsius. And again, these places are also dry. Not all the time, but sometimes they are dry, meaning that time you can cool it. And yes, you will exceed the nameplate rating. Meaning if the plate is like, it's 600 watt plate, you can get almost 750 out of it if you cool it. So cool it to 10 degrees Celsius, you're like, oh, you're getting more power. So, but again, we have to make sure that there is no condensation on it. Otherwise, salt will become a hassle. So fundamentally, this is the source. It will give you electricity. It's not too expensive. It's long-term sustainable, and it does not leach your oil reserves. So that's the whole point. Nothing fancy, known technology, tested technology. You just have to assemble it. So this is step 1. Step 2, you run a refrigeration cycle to leach all that energy away, because you can run that water system, but it will not allow you cooling. Basically, you will not be able to cool the panels. So, and the energy will be, basically there is a lot of energy. It's just that voltage is low. So if solar panels can work and give you that kind of thermal energy, why don't we run steam power plant with this? The problem with steam power plant is that people don't study it requires T delta. huge T delta, and T delta on normal coal power plant can be as high as 1600 degrees Celsius, meaning the flame is 1600 degrees Celsius. That's how you have high pressure water running in the tubes. They become very hot, and again, they are not only hot, they are also under pressure. Now you get a superheated steam, supercritical stream, that gives you the electricity, and that's only 30% efficient. So let that be very clear. You need bonkersly high temperature. Here temperature will only be optimistically 20 degrees Celsius above ambient. So if the outside temperature is 60 degrees Celsius, 80 degrees Celsius will be water temperature. That is not enough to do anything, even though the energy is there. Like energy wise, shut up, take money, that kind of energy is there. It's just that we can't do much with it. You can run organic Rankine cycle, but the machine will cost so much. It's like, bro, just buy more solar panel, it will be cheaper. So we have the energy, it's just that we need a stabilizer for it or a transformer. So ammonia is the transformer. So basically the amount of heat we are talking about, there are only few refrigerant that scales to that scale, and ammonia is the best in that. Why? Because panels need to be cooled, otherwise they will be cooked. So, and it will give us high temperature delta, meaning we can cool the panel and make sure the hot end gets as hot as our desalination requirement. So this is how you get heat for LTTD stage. And ammonia is best choice. Why it's the best choice? Because it's very efficient, meaning at this point in time, you can compare with almost all refrigerant available. Ammonia is like, I was, I am, I will be. There is almost nothing that can beat it, like flat out. The COP you can get on these puppies in adverse condition is like, damn. And it's low cost. Like the larger you make it, the cheaper it becomes. Like 10 ton AC, ammonia don't touch about it. 100 ton AC, 1000 ton AC, now you're talking. 5000 ton, now you're really talking. So ammonia starts to make sense at those larger scales, and they have very long lifespan. They do have consequence. You can't use normal copper or brass tubings. You have to use stainless steel, otherwise it will corrode. But it does have long lifespan. 30 years is like average, and scalable, meaning you can keep scaling that up here. Like you can start with a 1 gigawatt farm output, then you can go to 2 gigawatt, 5 gigawatt, go YOLO on it. It is scalable. And what about coefficient of performance? Because you do not want to burn all the electrical energy coming from the solar panel into the refrigeration. This depends on the depth, basically how deep you are pulling the water from ocean. If you are pulling the water, let's say 20-50 meters deep, the COP would be good. If you are pulling from 400 meters, like a case of India's low temperature thermal desalination, water temperature would be low, like 12 degrees Celsius low. If you have 12 degrees Celsius water for your condenser, yeah, your COP would be 8 or maybe even higher than that, like 10-12 is possible, because again, panels are reaching 50 degrees Celsius. Your cooling medium is at 15 degrees Celsius. Heat wants to go. Refrigeration cycle is like, bro, go. Bro, go. So it will be ludicrously efficient. That depends how deep you want. Now, again, why not go very deep and get 4 degrees Celsius water? Problem is the pumping losses will start to pile up. So you want to go be low, but not so low that all the energy you saved on the refrigeration, you end up losing in the pump. So there is a vector, basically based on the circumstances, based on the water temperatures, you can calculate what is the sweet spot. So, but COP wise, do not have to worry about it. Like you're gonna easily start with 5 COP or 6 COP without any issue. So most of your solar energy, 50% is like completely free. You will not touch it. Other depends on like how well optimized system is. So ammonia gives you that control. You can control how cool the panels are, and you can control how hot the hot end is. Now we use that heat. We use that heat into this thing, what we call low temperature thermal desalination. So basically you take seawater in large volume, like bonkersly large volume. So in this sort of scenario, in India system, that is like 400 meters, 12 degrees Celsius water. Now this is a small plant made for island nations. We have small islands. We wanted to make sure they never have to worry about water. We gave them that for 10 years. They're like, cool, chill. We don't talk about it because it works. So you have cooling water. Now that water goes into two sections. First the cooling, second small portion, very small portion you will leach out. That will become your heat for vaporization, meaning you put it in the warm water section. This is where your condenser is, condenser of your refrigeration. So 12 degree come in, it went into your basically submerged condenser or heat exchanger, whatever works there. And then you have hot water. Now how hot it would be? Not that hot. You only need to heat it up to, let's just say 28, 29 degrees Celsius, 30 degrees Celsius maybe. So fundamentally, this is where you dump the heat. Now, what happens to that water? Water is hot, but again, it's not going to boil. So you send it into flash chamber. Now, flash chamber, you pull a vacuum into it. And that vacuum, again, it has to be pulled through a wet pump. If you put it through a dry pump, it will clog up from water vapor. So it has to be a wet pump. So you spray them. Once you spray them, most of the water turns into vapor. Some falls back into collection sump and you recycle that water. Recycle does not mean like I actually sent it again to boil it. You do not want high brine content. So recycle simply means you let it go in the cold section. And the cold water cools the condenser, because if you do not cool the condenser, you will not get vapor, because again pressure will start to rise. So condenser removes the energy, and again that condenser is running from the main flow of 12 degrees Celsius water. Here you took that 12 degrees Celsius water, heated it up to 28 degrees Celsius water. That's how it got working. So this is the flash chamber. You run a vacuum pump. As long as condenser is cool enough, the vapor chamber would be cool enough, low pressure enough, that whole cycle works. And again, it's been running for 10 years. Like we got this, we know this is ancient technology. So fundamentally, condenser using unheated water, and all this has to be done in vacuum chambers. And fresh water, you get fresh water, awesome. And then you get diluted brine based on the concentration here. Basically, if you are taking, let's say 1000 cubic meter per second, and you divert 10 cubic, okay, very low brine. Even if all 100% of that water is boiled away, you don't want that, because again, you do want brine to be in liquid state, so it's easy to return and does not clog up the equipments. And brine concentration is so little that from sea's point of view, sea life point of view, yeah, it's a bit hotter of summer. So it's not that big of an issue. And what kind of water output we are talking about? For 1 gigawatt hour, aka solar farm that can be small scale, like let's say 300 megawatt, it will have 1 gigawatt of thermal output. You are looking at 1400 cubic meter of water, and with very mild brine. Like brine is not an issue here. 1400 cubic meter. And that's just a small plant, because again, this will be scaling up a lot. And again, you are not running out of heat, and not to mention in those sort of places, those close to equator, yeah, solar farm will work for 7 to 8 hours. So, and again, you do not burn oil for it, you do not contaminate the sea for it, there is no advanced membrane technology that you have to keep paying someone for that, or there is no chemicals involved also, and you are not burning your oil, and you are getting 50% electricity left that you can sell for your grid without any issue. So this is the best way to long-term sustain those people without any hassle. Now, what can we do in future? First is we have to move the thirsty sea, because there is a specific point here in this region in Iran that has a steel plant. And if you know anything about steel plant, they require bonkers amount of cooling. How the heck somebody thought that's a good idea to put there? So you move all those sort of thirsty industry, basically industry that consume water for cooling, you shift all of them to coastal area. And either you have a giant district cooling for those sort of plants, so you can have one dedicated giant low temperature thermal desalination, or each one of them can have it. So depending on the design, depending on the economics condition, you can decide it. So that way you can make sure that thirsty industry, instead of drinking water, they make water. Because again, that requires heat. If you have waste heat that you have to boil water away, why not boil water away in a sealed chamber where you're using water as a coolant? So fundamentally, cooling should not drink water. Let that be very clear. Cooling should not drink water, cooling should give you water if you are doing it right. And how would you transport it? Now, this is the biggest stupidity that Soviet Union created. I have no idea why Indians bought into it. I have no idea why Chinese bought into it. I have no idea why Iranian bought into it. It's like, what if we created a canal in a hot country? Like, it's hot. Like, bro, it's hot. And it's not Fahrenheit hot. It's Celsius hot. It's freaking hot. And people are like, what if we drain river here? It's like, bro, it will just boil away. Nothing else will happen. You're just going to have water. Gone. So thankfully, I have to say, Iran has understood that was stupid, and now they are building pipelines. It's like, it has to be pipeline. You cannot have water exposed to the air and sunlight. Again, if you have open pipe, it does come with one penalty. Water would be very hot here, but people will live with hot water, warm water, and all you have to do is wait and only drain during the just before sunrise. That time it will be the coldest. So fundamentally, you cannot use canals for transportation. That is like, no. And how do you store the water? Like, first you will like create as much water as you have. You take care of essentials. What after that? You have to store water at some point. Well, you have to make sure that under no circumstances you put it in open bodies. Like, you have a, even if you have something old, where it's like, hey, we have this, let's say, lake. What if we put water there? No. The best place to put water in Iran's case is because they have drained so much of their aquifers, basically underground water reserves. Their ground is sinking. That becomes the best place to put water in, because A, it has inbuilt distribution system. You do not have to worry about it. B, it has bonkers capacity. Like, bonkers capacity. Like, you can keep pumping water there and never even worry about it. It's like, if you keep pumping water there, it's like it will drink a lot. You do not have to worry about it. Now, agriculture, that was the weird thing. Heck, agriculture, India does have far higher water content than Iran. And even we are switching to basically drip irrigation to improve water efficiency. They have to do that. And find someone who the heck can explain to me why they are farming watermelon in Iran, sugarcane in Iran. I'm like, but again, they can still do it as long as they are water efficient. They have to be efficient. Now, what if they want to reduce their oil consumption even more? Again, more selling oil, more profit. They can go with this route. This is Israel. Chinese company built this. This is a closed loop pumped hydro, meaning you get power from solar, you dump it here, and during night time, you just let it run. And again, it gives you grid inertia. Again, it does not have lifespan limitation. The only penalty this versus a battery system, battery is a bit higher efficiency, as in round trip efficiency is 90 to 95%. Here, you're going to be lucky if you get 80 to 85%. But again, this will last forever as long as you keep maintaining it. We have older ones that are made into era of what we call nuclear fever. 1950s, they are still working. So that's a very long time. And again, if Israel have to do this or Egypt have to do this, they have to cover this part with solar panels. They cannot have naked water bodies. So that's the first thing. That way they can reduce their fuel consumption even more. Of course, they will have the power plants. Everything is fine. It's just like most of the time, why burn energy when you don't have to? Sell, make more money, let everybody suffer. You be economical. And from environmentalist point of view, be economical. So there is a lot of option. Let that be very clear. It's a solvable problem. It's just that dictators have to understand that fighter jets are more expensive than solar panels. Like, they have to understand that, like really understand that. So this was my presentation on how to solve Middle East. Again, it will not solve landlocked countries. Like, I have no idea what to do with Afghanistan, but it can take care of all the sea nations. So this was presentation for that topic. I hope you have liked it, learn from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.